This is a talk that I've been giving for about a year, a bit over a year, and it's been being refined over that time. At the end of the talk, I'll give a few links. I refer to lots of books in here. There's a book list at the end. There's a URL to a book list. There's also the talk track of this was turned into a sort of a little booklet. It's a mini ebook thing. It's about 9 pages. There's a PDF of that you can download, which is sort of all the stories and things, but expanded and turned into something you can read. It's called Cloud for CEOs, and the idea was to get something you could give to an executive to have them think about how they would be interested in innovating. So I'll put those URLs up at the end to give you a bit more of a reference, something to follow on from. So let's get going. So this is the context that we're in. Over a few decades ago, the kind of IT we were building, the old world IT, we were trying to manage employees at work. The factories and supply chain were just starting to get instrumented. Sales channels were indirect. There were shops. You sent something in a box of things to a shop, or you dealt with a travel agent, or you dealt with a bank branch, or you dealt with a TV station, right? That's the old world. And marketing was TV advertising, print advertising, and you asked Nielsen, how many people watch TV to figure out, how much you could charge for the advert. And that was kind of the business model. So we built IT for this world. And it tended to be on roughly an annual change cycle. So you'd go to one of the big industry exhibitions and you'd figure out what's the architecture going to be for the next year, because product releases were focused into this sort of annual cycle. So that was the old world of IT. The new world of IT, it looks more like this. We've got mobile applications we're building for employees to make them productive at work. The factories and supply chain fully instrumented, continuous supply tracking, much more detailed, huge amount of information. Sales is now online, delivery is online. You now know exactly who your customers are. You know where your package is as it's on the way to them. You're not sending a bunch of things in a box to a store. You're sending it directly to the customer. After that thing arrives at the customer, let's say it's a door lock, they put it on their door. It's an IoT-connected door lock. Now, if it doesn't call you every 5 minutes to say it's still online and the batteries are still good, you've got a problem. So the products you're shipping aren't fire and forget. They're now part of something that is connected to you. So now you have to figure out, how do you build IT for managing everything you've ever made, as well as every customer you've ever touched, rather than the number of stores you sell through or your supply chain. And marketing is now moved online. So marketing is now, what did somebody say about you on Twitter or Facebook 2 minutes ago? That matters. You have to be able to respond in real time. And advertising with real-time bidding, we're doing a lot more automation there. So the new world of IT has to deal with all of these things. And that's why, that's the big challenge. This is what my definition of digital transformation. This is what it looks like for organizations that have gone through that. So what that leads to is that now you know who your customers are and how your products are used. You can build products that are personalized for your customer. Many of you know I was at Netflix for a long time. Netflix is the first global TV channel that's personalized for every customer that sees it. Right? That's what they built that was new. They bypassed the TV stations, which were the gatekeepers to what you saw on TV before, and they went global, and they personalized everything. So everyone's experience of Netflix is different. Then you pull customer analytics to find out how are customers using your products. You've got to learn how to do that. You have all these new channels directly to the customers, whatever kind of customer they are. But from an IT perspective, we have vastly more things to manage. They're at much larger scale because they scale with the number of things you've ever made and the number of customers you've ever touched. And the rate of change has now moved from annual to just continuous. And this is all of the things that's been driving everybody crazy and getting everybody to figure out, how do we innovate at this speed? What AWS has been doing, and what I've been doing going around talking to people for the last few years, is unblocking this innovation, picking up ideas from one customer, and looking at patterns across the industry, and figuring out what are the best practices and what are the good ideas, and what gets in your way, and what kind of stages you go through. So I'm going to talk now about the different blockers for innovation. These are the 4 types of things I see getting in the way. And a bit later on, I'll talk about the stages you go through. Start off with culture. This is the kind of problems we have. Centralized, slow decision-making, which is actually appropriate if your products and your architectures are changing annually. You can actually centralize decision-making. It's fine. It's a very efficient way of working if you're working on a common architecture which is moving slowly. But at the pace that we're moving today, we can't do centralized, slow decision-making. We have to make it, devolve it down into individual teams. That means you now need to trust teams. So lack of trust gets in the way. And then very inflexible policies and processes get in the way. These are the patterns I see in organizations which are struggling. There's a lot of good information, beginning of a few different books here. Ahead in the Cloud by Stephen Orban is really a summary of best practices of how to move to cloud. And Mark Schwartz, who's wandering around the conference somewhere, if you see him, say hi. He's written a series of really interesting books. A Seat at the Table is how to be an agile CIO. Because he was a CIO at the Department of Homeland Security, Immigration Naturalization Service for the US. And he was looking at how the best practices for being a CIO, and they were all waterfall, very slow, nothing, none of the DevOps ideas were in there, none of the agile ideas were in there. So he figured out what that looks like to be an agile, DevOps-oriented CIO and get a seat at the table because you're now contributing to the business, you're not just a cost center. That's what the title's about. And then more recently, he released another book, which is for everyone else at that table, how to use IT as a competitive weapon, how to think about IT to build your advantages in the new world, and that's War and Peace in IT. Lots of Napoleonic War references and things in there. Anyway, so a lot of this comes down to culture. This quote, if you want to build a ship, don't drum up the people to gather wood, divide the work, and give orders. Instead, teach them to yearn for the vast and endless sea. So the idea here is you give people purpose and get out of their way, and they'll build a better thing than they would build if you micromanage them to build the thing you had in your head. That's the idea. This is one of Reed Hastings' favorite quotes. It's at the beginning of the Netflix culture deck, and it sort of is his distillation of the idea he had for creating the Netflix culture. Nordstrom have an interesting thing where they boiled it down to just one word, judgment, right? If you use good judgment in all situations, that's fine. This is a universal rule for culture. And this is the kind of culture we want. It means you're empowered to use your judgment. But you are using good judgment, and you're going to check up. So this is the trust but verify model. We're trusting that you're going to use good judgment. We're going to verify that you did. So you have to think about everything you do. You're not just blindly following processes all the time. So this is the full set of Netflix sort of culture values. Freedom and responsibility is one of the key ones that they emphasize, right? You're free to do whatever you want to do, but you're responsible for the outcomes, and we're going to hold you accountable for it. And if it doesn't work out, you make a few bad judgment calls, we'll trade you for a better player. So Netflix is a very integrated organization. It's in really one location from a technology point of view, and it's trying to build the world's best sports team at what they're doing. They treat themselves like an Olympic sports team, and they will trade players, and they find the best players in the world, and that's their goal. And whenever you're playing against Netflix, you're playing against the best funded team with the best players. That's the model they want to operate on. It works if you're a startup and you're trying to build a very focused business that's doing one thing. You're trying to win at one sport, right? So Amazon culture is a little different. Amazon is now, whatever it is, 750,000 employees, something like that, around the world doing all kinds of things in lots and lots of places. We have to manage the diversity across our culture. So what we have is these leadership principles, which everyone at Amazon is hired against these principles, promotions and annual reviews, and it's in all the documents we write to each other, and it's in conversations we have with each other. I was talking to somebody yesterday or this morning, and they said, diving deep on this thing. Like, it's absolutely getting into and thinking big on what they were doing. So there's all kinds of stuff here where it gives us a common language for cooperating across an incredibly diverse large organization which is moving at very high speed in many different directions. So the key thing about culture, be intentional about culture. If you aren't, culture will happen to you. You'll end up with a fractured culture, like a warring tribes culture. And it wants to be appropriate to the kind of business. Are you building something that's very focused, like a startup, the kind of Netflix culture, or are you building a large, multinational, diverse organization? Again, the cultures need to be different. But a lot of these cultures are really based on judgment at the bottom and the use of good judgment. So let's look at skills. Everyone says, well, I can't hire the people I need to build a cloud. Well, you've got the people. Train the people you've got. And this is the successful pattern we've seen. Lots of organizations just going in and just doing mass training, and it's a very good outcome. You also want to fund Pathfinder teams to go and learn how to do things, but you also want to think about incentives. What's the incentive for an employee to become trained? And what's the incentive for an employee to stay with you once they've become trained? Because obviously a highly trained cloud engineer is worth more than somebody that wasn't, that's trained, an expert in some obsolete thing that nobody cares about anymore. And if you train up people and the company down the road hires them from you, you're just training people for a brain drain. So think about that and think about what are the incentives. Different organizations have different kinds of incentives. It could be, glory, sort of pat on the back. It could be some shares. It could be a bonus. But what you should think about doing is saying, these are the technologies we care about in 2020, and publish them. Say, if you can become qualified in cloud or machine learning or something else that matters to the company, and you can get a qualification this year, we'll give you some recognition for that qualification. And that sets up a systemic incentive for employees to continuously learn the next technology you're going to need. And that feedback loop will keep you on top of things, and it'll mean that people feel invested in and they feel that they're more likely to stay. So it helps retention. If you really want to disrupt your HR department, give them this book. I've seen HR people go red-faced and stuttering, like just explaining some of the ideas in this book. It's one of the most disruptive conceptual ideas to hit the sort of human resources people for a long time. And it's the sort of model of how Netflix thinks about it. I won't go into it in great detail today, but if you think you've got some good innovation going, you really want to get the most out of your employees and really give them a lot of power, there's a lot of good ideas in here. The caveat is that Netflix culture was designed to be hard to copy. Sorry. It's a competitive advantage they have in the market. They can tell everyone about their culture, and it's incredibly hard to copy, and very few people have done even a fraction of what's in this book. So it's very annoying as well. This is really the hardest thing to do. Reorgs are difficult. What you need is product teams that have long-term product ownership, that do continuous delivery. They're doing DevOps, they run what they write, and that also reduces technet and lock-in because you own the technology, there's always a developer on the team, you can always design something out. If you think about a project team where you form a project team and then they hand it over to operations and the development team goes away, that's kind of a typical project, and then you're just running something. When you're just running something and there isn't a development team on it, you're locked in. Whatever database they chose once they were building it, you're stuck with that. So you have to form a new project in order to upgrade or change. So that's the big difference. You're in a continuous development and continuous delivery approach. There's a few good books here as well. Project to Product is just a distillation of this idea. And the DevOps Handbook by Gene Kim gives you lots of great ideas about how to get DevOps to work. But I wanted to talk a little bit more. Let's go beyond DevOps. A lot of people got the idea we should get development and operations to work together. And then some people said, well, let's make them one team. And that's the Netflix, Amazon, and a few other organizations. They put one team. And that team does development and operations. They're just different roles within a team. They aren't different teams. They aren't different parts of the organization. But what AWS does, it actually puts the business and the product in that team. So an AWS service team is a business which has a product manager who owns the roadmap and the gathering input from customers. And they also own the development and continuous delivery of features. And they operate the service. They're on call. They use a lot of automation, but they are globally supporting that product, that service, right? So this is fully integrated. So there is, if you think about a lot of organizations, there's IT over here and there's the business over there, and we work for the business and we do stuff for them. There is no the business at AWS. The business is the services, and the services own their own development. So it's a radically different approach. It's much more cellular, and it scales, and that's really the interesting thing here. And the way, just to put it sort of into an org chart, if you have Andy Jassy at the top, we have sales, we have marketing, we have services. At the VP level, will be a bunch of related services, and the general manager, there's a bunch of more closely related things under a general manager. And then you've got the actual service manager with one of those 2 pizza teams that with 10, 20 people, something like that. And they do business, product development, operations, and you talk to them through an API, and they talk to everyone else through an API. And this is the sort of canonical structure. This is a bit of a cartoon for it, but not everything is exactly like this. But this is how to think about the way AWS is structured. Product marketing has the interesting problem of taking a bunch of services which are sort of from different teams and trying to turn them into something which we can market as an overall sort of section. So the things that you see have been sort of digested by product marketing to try and make them into consistent areas, right? So we have different themes we have in product marketing to pull out all the different service teams and pull the different pieces together. So that's where the sort of customer visible piece is really sort of managed from the point of view of trying to make sense of it. This is another interesting pattern from AWS. It's sort of the weekly cycle of how we do learning as an organization for operational quality. And again, this is sort of a cartoon version of it. The details are a bit more detailed. But every Monday, every one of these service teams looks at what happened last week. They look at their business metrics, how well they did, how they grew, if they're revenue generating, how much revenue they made. And then they also look at their operational dashboards. They look at the wiggly lines and say, well, what was this glitch? What happened here? Did we do some updates? What happened operationally? What was our operational quality last week? And that happens on Monday in a meeting. The results of those individual service team meetings are then rolled up and discussed at the general manager and the VP level on Tuesday, Monday afternoon, Tuesday. And then Wednesday morning, there is a meeting which has a representative from every service team. Every single service team has to have it. It's a huge meeting. They're not all physically in the room. A lot of them are. And they review all the operational issues that happened across AWS. Any customer issues, any upgrades, any transitions or retiring of legacy, or all these different things we're doing, and any failures that happened during the week. And this is where everybody learns from everything that happens. So if one team has a failure of some kind, every other team will hear about that. So the way you get everybody to be at that meeting is towards the end of the meeting, they spin a roulette wheel that has every service team's name on it. And that wheel comes up, and whichever team is picked at random has to then get on the call and has 10 minutes to describe what happened last week to them. They run through their weekly metrics. They have to explain it. So one, if you're not on the call, you'll get paged. It's actually a serious thing to not be on the call. So some representative has to be there. And you have to be able to make sense to everyone else of what your metrics and your dashboards look like for last week. So that forces you to do that Monday meeting and to really understand what happened, because you could be called on it. And, every now and again, somebody's embarrassed because they didn't spend quite enough time on it. But the roulette wheel, we open sourced it a couple of years ago. So if you want to set that up, this is actually a pretty good practice. I found quite a few companies actually starting to do something like this. There's a second meeting that looks at all the business revenue and goals and deep dives on each individual business. Again, it's more of a business executive sort of VP level meeting. So that's a pattern. So that sets up a weekly point check-in to get operational quality across all these teams. Because if you have lots of very separated teams, you've got to have a way for them to share information. The other thing is just like internal We have internal video. Once a week, there's one of the principal engineers will give a talk about how something works, called Principles of Amazon. The principal engineers talk about the principles of how Amazon works, and those things are shared broadly. So there's ways of sharing new technology on the developer side and ways of sharing in the operational. So it's very important to get these in place. Okay, if we look at it from a risk point of view, one of the issues you get is in finance, where they're trying to, different different organizations, different CFOs have different attitudes. Some people are very hung up on capital expense. They're capital-intensive businesses. They're used to managing CapEx. They like capitalizing their data centers. So when you say, I want to move to cloud, they say, where did my CapEx go? How do I deal with this? Other people are actually happy to move to OpEx. So it's a little bit different. But both two transitions make a difference here, and you need to make sure that the CFO understands what's happening. If you're doing a large transition to cloud, you will be moving a fair amount of capital to expense. And there are ways to finesse that, but it depends what country you're in and what the local accounting rules are and what the opinions of your CFO are. Also, if you take development and operations as two separate things, you typically capitalize development because it's an asset, and you expense operations. If you combine the two together into one team, you have to come up with new mechanisms for how you deal with that, and there are ways of dealing with that. But again, it's a different pattern. We've seen a couple of times where cloud transitions sort of screeched to a halt because the CFO said, no, you can't do that because it's going to mess up next quarter's EBITDA numbers or something, and we've predicted what they should be to the street. So you have to be careful sometimes when you're getting into the later stages of a transition and significant amounts of expense are moving to cloud. Another thing I want to talk about is boards. So you go talk to all these companies, say, well, why can't you get this done? Well, we have rules that say you can't do that. And you go like, well, why? And eventually it turns out the problems in a lot of organizations are at board level. So I started trying to distill this out and come up with some sort of ideas about what was going on. And I've spent some time interacting with board members and working at that level with some organizations. There's a really interesting book, and if you're interested in what happens at board level, this is actually quite a fun read. I was sitting on a plane. I read it in one sitting all the way through. It was really interesting. So, Risto Salasma. Okay, Nokia. What does Nokia mean to most people? If you're if you had a mobile phone a decade ago, you probably had a Nokia phone, right? That was sort of the 2008, 2009 normal phone, and now they barely register as a phone company. So Risto joined the board of Nokia in 2008 at the peak of their success, and he found a board which was not operationally involved in the company. There was a lot of dysfunctional things going on in that board, and the first half of the book is a story of how not to run a board, which is way too familiar to many large organizations which are being held back by their board. Then Transformer crashed and burned and got basically taken out by the iPhone and Android. Ended up selling their phone business to Microsoft. And that story is in this book. There's a whole lot of last-minute stuff and really interesting sort of business maneuvers. If you want to see what a corporate takeover looks like, it's actually one of those sale pieces. A sell-off looks like. And then he was actually made the CEO of Nokia for a while, and then he rebuilt them onto a new strategy, and then moved back to being chairman of the board. So worth reading. So what do boards worry about? Compensation, executive succession, oversight of finance, risk, and strategy. Sort of the high-level things. There's committees in some boards for each of these subjects. And all of those affect your ability to innovate, but they may reduce innovation. And please be more innovative. Like this is in board-level discussions across the US and across the world. People use these companies as examples of innovative companies. And I've worked at two of them, and I've spent a lot of time with Capital One as well. So what is the patterns that work and what doesn't work? So here's the problem. Most boards work like this. There's a short-term focus on compensation, non-technical executives, they have capitalization, there isn't any investment money, We don't want you to take any risks at all. We don't want anything to ever fail, but we still want you to be more innovative. And this doesn't work. I mean, I've had board members get like PTSD-like reactions, see, from this slide. Yeah, that looks like us. How do we not do that? So if we take a group that wants to do something, product team would like to use cloud, they'd like to make a better product. Can't use cloud because there's processes and policies that say we can't. There's our org chart, won't let us change those, but DevOps is a reorg, so that's a problem because org charts are sort of CIO level discussion. We want to reduce the number of project management staff by moving project to product because the project managers keep getting in the way. And we don't have project managers when we don't have projects, so they get all grumpy and stop the process. We can't change the org chart because of culture. We can't change culture because incentives aren't aligned. And this all sort of builds up. You kind of get the culture you pay for. Like incentives have to be aligned with the culture. You can't change incentives because the compensation policy isn't flexible enough. And then the board won't change the compensation policy because they're implementing current best practices, and that's low risk. And that's like the fundamental reason why, if you sort of trace back why you can't change something, it's because that's a best practice and it's low risk is the common answer you get. So what do board level patterns look like? What successful patterns? This is what it looks like in the more successful organizations. Compensation policy understands that you want to have fewer higher paid staff with more ownership, and that's kind of the pattern. It's the people are more invested in the success of the organization. You're not trying to replace expensive developers with cheap developers overseas. You're trying to develop more leadership and in your own internal development organization. Technical competence for executives, managing those expectations and investing in differentiators, in particular, not building out new data centers and moving to cloud is an example of that. This is really important. Smaller projects with incremental returns and focusing on time to value. And what that does is lets you get out of the way of innovation. So these board level concerns, basically best practices that minimize short-term risk get in the way. But there are ways to get out of that. So let's look at the pathway for innovation. First of all, we want to learn to go fast. Let's do small, easy things quickly, because if you can't do something small quickly, there's a problem. Then we want to learn to run at scale and build large-scale applications that are distributed, they're optimized, and they have high capacity. And then we want to move to the strategic workloads. So data center replacement, those really critical workloads that run the business. And this is the key point. You're not adding innovation to organize. Hiring a VP of innovation doesn't really change anything. Getting out of the way of innovation across a whole organization is what makes the biggest difference. So this is like the subject, the key point that's in that little booklet I told you about. The fundamental metric for innovation, if there's one metric you can go look at, it's time to value. Because if you do some work, how long does it take for that work to reach a customer? That is the innovation, is the value to a customer. So how long does it take? And some organizations, it takes months. And that's kind of hard to be innovative, where every idea you have is going to take months to happen. Maybe you're doing days, a week or two, that's better. But a lot of organizations now, it's minutes, because that's what continuous delivery gives you. We have the technology now to make a change, and for that change to deploy to production, actually in seconds, really. But minutes is more of a reasonable thing, right? So a few minutes after you've written a line of code, it could be running in production. There's no reason, the technology exists to do that, so you should be leveraging that to support innovation. So it turns out that this is another problem. People think that if you bundle things together, it gets more efficient. And the problem with software is the more you bundle together, the harder it is to release. There is more interactions. Like if you double the amount of code in a release, it's going to take more than twice as long to test, more than twice as long to release. So if you halve the amount of code in a release, it'll take less than half the time. So you work all the way down until you're at really one line of code or one small change or a day's worth of work. Something like that is a good size to deploy. So what you need then is an automated continuous delivery pipeline. You've got to use tagging and feature flags and A/B tests for everything that rolls out. So all your new code you're writing is behind a feature flag. It doesn't see, customers won't see it until you're sure it's working, but it's in production. The key thing is your code's in production, and if anyone goes to modify it, they see that production. So rapid, cheap builds are also important. Somebody was telling me, oh, this is what sounds excellent, but our Java build takes 9 hours. Yeah, all right. Well, maybe you shouldn't be using Java, and maybe you shouldn't be doing a monolith, right? Because it really, if you type go build, it usually just returns. I mean, like the prompt just appears, right? I've written some fairly large Go programs a few years ago, and it's just like it was pretty hard to get it to take more than a fraction of a second. So, yeah, but your Java monolith could take hours to build. So that's, the technology is there to solve for that problem. And also, we should just be changing one thing at a time, because it's easier to tell if it breaks. It's easier to roll back to the previous version. It's easier to measure that time to value, because you've got a clear idea of what the small thing was when it started and when it ended. If you've got 100 people contributing to a monolith for 3 months, when did the time start for the time to value? It's kind of fuzzy. You know when the end point was, when it was delivered, but the start is fuzzy. It makes it harder to remember. So you want to decouple new code from new features with feature flags. So this is a summary of it. Small changes give you less risk, faster problem detection, faster repair, less work in progress, much less time merging changes because the changes don't diverge for long. Right? If you take a branch of some code and you work on it for a month, and when you try to come back in, everyone else has been in that code. It's going to take you a lot longer than if it was yesterday's code and you're putting it back today. Happier developers. One of the nice things about Netflix, we'd work on some code, go home, watch TV, and see our code in action. Right? That's very motivating, whereas like putting code into a system and not knowing if that code will ever actually see the light of day in a year or so after you've left the company, that's much less interesting. And it gives, if you're a product manager, it gives you faster flow as well. So how do we get there? First thing is measure time to value. Find ways in your delivery pipeline to measure this. Automate collection and reporting. Learn to do small things quickly. If you have a delivery pipeline right now that takes months, yeah, you can try speeding it up to maybe take 2 months instead of 3 months by accelerating it a bit. But what you should actually do is create another pipeline that takes, say, days or weeks, something significantly faster. We've seen a few customers do this. A big bank, 3-month delivery pipeline. They developed a 2-week pipeline, which had, to get into this pipeline, you had to meet a whole bunch of criteria. Like, it's got to be a small, safe, easy change that really has not got anything critical in it. And then they've had more and more people using the fast path for all those usability changes, right? Particularly customer usability, you want to get that iterating quickly. Yeah, changing the core banking system, yeah, we'll take 3 months to check that in. But we'll get the usability stuff going. But then they found something really interesting. One of their core banking big products was released by putting every piece of it through the fast path, by breaking this huge project into lots of small, innocuous pieces, and they snuck it through without telling anybody that's what they were doing until they'd finished releasing it. And then they said, hey, we just released this thing. We did that whole thing through the fast path, and wow, this is cool. So everyone said, go figure out how to do that. So it can be done. What you're doing is you're setting up an incentive for people to find a path of least resistance. Again, it's more systems thinking approach here. The other thing is measure cost per deploy. What is it actually costing you to do a build in dollars, machine time? How many meetings, people hours in meetings do you have per release, right? Get that down. There should be really one tracking ticket for a release, and there should be, you should have no meetings for a release. You can have a meeting about a roadmap for something, but not about a release. There's a whole bunch of good books here. Hypothesis-driven development's the key thing in Lean Enterprise. One of the authors of Lean Enterprise going around the world trying to get people to implement it found that the problem was not the new idea, the problem was unlearning the old idea. So He wrote the book Unlearn. And he also managed to hack the New York Times bestseller list by referencing, I think, is this Serena Williams? I think it is. But famous tennis player, referenced her in the book and did the whole story about her and her coach and how she reinvented her game, then gave a copy of the book to her, and a photo of her reading the book was taken and put on in a newspaper. I think it was the Daily Mail in England or something like that. So if you ever write a book, put a celebrity in the book and get somebody, paparazzi, to take a picture of the celebrity reading your book, because this made a big difference, and it's a good way to hack the bestseller lists. Anyway. Principles and theoretical basis for using consistently small changes. This book's pretty deep technically, but it really gives you a good theoretical basis for everything. And I've mentioned this book a couple of times. If you're getting rid of projects and moving to products, really is, I'm sorry, but about 90% of the project managers, you don't need them. You still need a few for cross-cutting projects, but they shouldn't be in the flow of managing a release. Whereas if you've got a year-long release or a 3-month-long release, you need a project manager to make sure it goes well. Survey data showing that low latency time to value does work. It's correlated. It's not just correlated, it's causally correlated with better outcomes. Happier companies, happier employees, higher stock value, faster growing companies are the ones who are doing this right. So what we're trying to do here, we're trying to learn to do simple things quickly to unblock innovation, avoid complex one-size-fits-all processes. But the best architecture today, and this is, if you're an IT architect, this is a little uncomfortable. It's minimalist, messy, and inconsistent. You can't have a nice, tidy IT architecture today. It will be too frozen in time. It'll be obsolete before you can write it down. That's an anti-pattern. That works if you're on an annual cycle. Remember the old school IT? Where, once a year you get a new IT architecture. No, it's changing all the time now. But you need guardrails. You have to say security, scalability, and availability. This is what we need. I don't care what language you write it in or where you get your code from or whatever, but it has to be scalable in this way. It's got to be available, and it's got to be secure. And it's designed to evolve rapidly. So the best IT architecture now is the one that is designed to evolve rapidly and absorb the new technologies and services that are coming out every day. And particularly if you're dealing with AWS, right? How many, last week we were releasing several hundred features a day or something. Low latency continuous delivery is the key thing. All right, so that was speed. Once you've learned to do simple things quickly, the next thing is those large-scale applications which are feeding the, think of that IoT backend or that mobile backend for that large service. This is net new software, right? This is where you want to be cloud native. It's going to be highly scaled. It's going to be globally distributed, cost optimized. It's going to auto-scale. It's going to be a very efficient, large-scale system, and you get to build this the new way. So if you're building cloud native, here's the principles. You pay as you go after you've used the resource. So if you want something to cost less, tune it up and the bill will be less next month. That doesn't work in the data center. If you tune something on the data center, you just got a machine that's got more idle time on it next month, right? That doesn't help. But cost is a key part of the equation. So you can be inefficient on day one, but then you can tune it and tune it and tune it to get the efficiency you need. It's self-service. You want everything to be API-driven, no waiting. Globally distributed. Have 20 or so regions that you can deploy code in, and with outposts, we can add even more to that. So we're going to have the ability to deploy the code to wherever it needs to be. Your availability models go cross-zone and cross-region. I'll talk more about that later. Very high utilization. You should be targeting many times higher. I mean, typical data center utilization is maybe 10 or 15% busy. And half of that is the agents that you're running, which are like checking security and configuration. There's a little bit of it is actually your code running. Right? If you're running Lambda, all of that stuff goes away. I mean, you just get 100% utilization. But even if you're running scaled EC2 instances or containers, you want to have them, if they get idle, you want to scale down. You want to run, say, 40 or 50% busy as your target utilization rather than 10 to 15%. That way, your average number of machines is, say, a quarter of what it would be in a data center. And you don't need all that extra capacity, like for peak traffic, on that busy day, or everyone logging in at 9 o'clock on Monday morning. All that stuff should be elastic. So you end up with better capacity guarantees and lower cost. But if you don't drive the utilization high, you'll end up with a lot of very underutilized machines in the cloud if you just copy them across from the data center. So now I'm going to do a little analogy, because people say, well, should you use containers or should you use serverless or both? And it's really both, but what are they each good for? And I'm going to say that we have this user need to build something which looks suspiciously like a toy spaceship. So let's say we're trying to build a model spaceship quickly and cheaply. How would we go about doing that? Traditional development, you design a prototype, get some AutoCAD out, you carve something out of modeling clay or 3D printer prototype. You make some molds out of that. You produce the injection molded parts. You assemble the parts together. You go back a few because they didn't fit and make some new molds, and you keep messing around until you find something that fits. And then you've got this toy. Most of you have probably had one of these somewhere at home. Your Millennium Falcon plastic model. There's a lot of them out there. This takes a while, right? It takes a few months. So what does rapid development look like? You get a big bag of bricks, you get a few plans, and in a few hours, and this is my favorite PowerPoint animation of all time. I don't know. I told someone make a Lego spaceship and they sent me back this. So it's like, yeah. If you have my GitHub account, you can find the link to the people that do my slides. It's a cool company. Anyway, I'm going to do that again. It's just so cool. All right, there we go. Hey, bricks falling. You can go read the PowerPoint for this. I have no idea how to actually do that, anything like that. So this lacks fine detail. It still looks a bit like a Millennium Falcon, but it's got sharp corners, right? But it's not exactly what you asked for, but you'll still play with it. Easy to modify and extend. You can add bits to it. And think about the lifetime of the Lego bricks. Like Lego bricks I have Lego bricks from when I was a kid. I could still use them today with new Lego bricks. There's like 40,000 different Lego bricks out there now. Back when I was a kid, there were a few, way, way fewer. So think about the longevity of this architecture. The individual pieces that it's built from are very, very long-lived, but the actual shape of it can mutate over time. Whereas that Millennium Falcon plastic toy you had for a few years and sat in your closet got thrown out years ago after it got broken because it's not flexible. So that's the difference in a flexible architecture and an inflexible one. But you still have to modify what you ask for to fit this, right? So you have to say it's okay to have sharp corners. It's okay for it to be this big, but not slightly bigger or smaller. And you're spending a lot of time figuring it out. But still, when you build these building brick-based architectures, you might find things that don't work so well, so you want to build some new specialization. So form a new custom brick, right? And you see this with Lego. They make new nose cone-shaped pointy bits all the time. So what we're doing is post-optimizing by building a new component, which takes longer, but we're not having to build the whole thing. So if we compare these, instead of full custom design, we're using building bricks. Instead of months of work, we're doing hours of work. And this is the biggest difference. Those of you that have done serverless hack-based hack days, you can build stuff, ridiculously complex things that will scale, that are pretty stable in a few hours or a day or two. Whereas if you built that full custom, you'd be spending weeks or months. There's too many choices if you want to just build something from scratch. You can spend a lot of time in architectural designs. In fact, you can spend more time arguing about how to architect your system and how to deploy it than it would take to finish building the whole thing if you're building it serverless. So the constraints help. But you still got to work around those constraints. So if we think about this as containers versus serverless, your containers are great for building custom code and services, and serverless is great for using events and functions and sort of gluing together those services. The choices are much more restricted, but that can be a benefit if you use it right. And you build together all of those blocks, and then every now and again you say, I need a new service, so I will go and build a container-based service that gives me lower startup latency, or it runs long-running jobs, or it's storing data somewhere, or you've got very predictable high traffic. You can auto-scale up and down, and the machines are always there. So that's where containers are really useful. But what I'm really advocating for here is serverless first. Use serverless for rapid prototyping almost anything new you want to build, because you will really get something done in a few days that will at least be roughly the right shape, and you can decide and iterate on it and decide if that's what you want. And you might go back and build most of it or some of it as a container-based service later, but at least you've got your prototype. So I'm going to talk a bit about some observability and failure modes a little bit. So we need to think about observability and some epidemic failure modes and a bit about chaos theory. Observability is defined in this control theory paper back in 1961. System's observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. So what that means from a computer system is, this is why you added that printf statement in the middle. You are making the output, you're making something inside the system observable, right? Or logging or whatever you do in your system, right? Now, another thing here about control theory and models is all models are wrong, but some models are useful. So we have to think about how are we modeling the behavior of our systems as well. Now, if we think about observability, at the bottom here, a monolith without any logging, it's pretty hard to figure out, or with logging, you can kind of see what it's doing, but it's hard to see what's really going on inside it. If you add tracing with an APM tool, you've got much better internal visibility, so your observability is better. A microservice that does one thing is inherently more observable because it just does that one thing. It doesn't have the complexity of all the different code paths that go through it. And if you have a function with no side effects, it is inherently very observable because you can just execute it n times. It will do the same output. It will produce the same output given the same input. That's what a function means. And that a function without side effects has a very fixed transfer function. That's what you're optimizing for. So this is an interesting book. How many people here have seen this book? A few of them. I've been trying to get more people to read it. Nancy Levison's at MIT. She worked on the team, and lots of the examples in the book are the air traffic control system for the US. I think that matters. They worked on making that reliable. And the nuclear launch system for all the missiles and things. So yeah, we want that to not accidentally launch missiles just because some software had a bad day. A lot of accident modeling here. So I'm trying to turn this into something that's maybe a bit more digestible. This is the model, and there's 3 layers in this model. At the bottom's the control process. That's the business logic. That's the code that you built to do a thing, right? Above that, there's an automated controller, which is controlling that process. And above that, there's the human controller that's watching what's going on, right? The operator, if you like. If I change the names on this, maybe it makes a bit more sense. Let's assume we have a sign-up flow microservice. Probably every website in the world has a sign-up flow, right? You have customer requests poking into one side of it. Out of the other side, hopefully you get new customers with all their information registered, right? Above that, you've got an autoscaler that's looking at the CPU utilization. And if the sign-up flow gets busy, it scales up the autoscaler, right? So you want to have something like that, right? So when there's a big inrush of new customers, your system scales up. And when there's not so many, it scales down. So that's pretty normal. And above that, there's a human controller looking at throughput and saying, do I have new customers turning up? And if that goes to 0, they get upset and go look at what's going wrong, right? So there's something like that happening. So this is a fairly common pattern, but laying it out in this way is the key thing. Is you, instead of looking at what could go wrong with the boxes here, you look at the hazards are the wires. You can kind of look at the boxes or the wires. Look at the interconnects. Look at the information that's flowing. So you look at what happens if the throughput sensor that's feeding the human controller goes haywire. Now you can't see what's happening. The controller might do something stupid like rebooting the machine or whatever because they think it's gone down, right? Or let's say the CPU utilization is coming through, but the sign-up flow is actually out of memory instead of out of CPU. You're not monitoring the right thing. So there are hazards involved in all of these things. So you're doing a hazard analysis on all the data flows in between the different things, rather than saying, what's the probability that this piece of code fails or something goes wrong with this box? You're looking at what's the probability, what's the outcome of a hazardous flow of information. That's the essential difference. I'm doing a talk this afternoon with a lot more information on this. Okay, so failures. People generally assume failures are independent. Unfortunately, a lot of them are correlated. They happen together as groups, and they can be epidemic, where everything breaks at once. Epidemic examples. Leap second bug took out a whole bunch of Linux machines at once. Memory leaks in an agent will leak over time. Every agent that gets started at a certain time, they'll all tend to memory leak into the same state. Anything that goes wrong with a cloud zone or region is an epidemic failure. DNS, one of the easiest ways of breaking everything in the world. Or security configuration. If you can kill DNS, like everything, forget it, right? We're done. And security configuration, sending out a configuration file missing a semicolon will take out most of your machines if you manage to automate deployment of it. So you need some way to quarantine these. And that's generally, if you have an epidemic, use quarantine. So what is your quarantine mechanism? Maybe you deploy in Windows as well as Linux, in case Linux has another common bug. You want multiple monitoring tools in case one of your tools fails. You want to use cross-zone or cross-region replication. Multiple domains and providers is a good idea if you're very dependent on DNS. And limiting scope of deployments, rolling deployments around the world is how you manage configuration errors across cloud regions and things like that. So you've got to manage diversity to contain an epidemic. You've got to have different ways of solving for problems. So that's the scale piece. Let's look at these critical workloads. What we're seeing now is a lot of customers moving their critical back-end things to the cloud. So we have a deal with Volkswagen where we work on the industrial cloud. There's a lot of work here, but it's the entire supply chain, factories, dealer networks, everything that Volkswagen does. How do we move all of those things to the cloud? It's a huge project. That obviously needs to be working, and there's safety critical things in there. So what's happening is these migrations are happening now for business and safety critical workloads. Travel, we have a number of airlines going all in on AWS. We have banks, financial organizations moving more and more workloads, healthcare, manufacturing. So, who here has a backup data center? Yeah, a few of you, okay. How often do you fail over apps to it? Usually this is where I get the embarrassed look, right? If you're a bank, the answer should be at least once a year because the auditors come by and make sure you do that. That's one app at a time, though. How often do you fail over the whole data center at once? And at this point, most people go, maybe we did it once, or it happened to us and we discovered it didn't work, so we didn't want to do it again. So I call this availability theater. Basically, you've spent all this money on a backup data center you hope you will never use, and if you ever have to use it, you'll find that actually nothing is in the correct state to get it done. So we have this lovely fairy tale we're running. Once upon a time, in theory, if everything works perfectly, we have a plan to survive the disasters we thought of in advance. But if anything actually happens, we usually end up in a bad way. So here's a few examples. So what would happen if you forgot to renew your domain name for your company? This happened to a SaaS vendor where all of their email and the product was at the same domain, and that domain no longer resolved. So product offline, email offline, every service and everything they had was offline. We had the CEO apologizing on Twitter for about 2 days. That was the only communication the company had left, other than bits of paper and third parties. Not good. So think about what would happen if something went wrong with your DNS. This has happened to everybody in the room that's ever run anything, I'm sure. We've worked very hard at AWS to track all our stupid security certificates and their expiry dates. We have systems and systems and systems and ways to track those. And it still happens very occasionally to us, too. So it's new things when they come in. We go, now, did you really find all of them? Anyway, turns out computers don't work underwater. Don't put your data center in the basement, in a flood, near the sea. If you put it further up, don't put the generators in the basement, and then it turns out putting the fuel tanks is also in the basement is also a bad idea. So there's lots of ways this can go wrong. Hopefully not you tomorrow. So what can you do about it? One thing is to get really good at fast detection and response. And Chris Pinkham was the original engineering manager for EC2. This is the part of the AWS philosophy. We really spend a lot of time on being very fast at detecting things when they go wrong and responding quickly, because once you've got rid of all of the normal failures, the obvious stuff, and the things that occur occasionally, the only kind of failures you have are extremely strange, Byzantine, weird things that no one has ever seen before. And that's the only kind of failure you'll get if you're running a really tight shop. We saw this at Netflix, we saw it at Amazon. You know, it's like you get complacent because you've caught all of the stuff that normally goes wrong. So you have to get really good at that. So it turns out networks aren't reliable. You can drift into failure. You can do the right thing at every possible stage and still have a catastrophic failure. So there's a whole book about that. If you're trying to get software released, Michael Nygaard, the first edition of this book was really useful. He did an update, added a few more things. This is where the circuit breaker idea came from, but the whole idea of building bulkheads for defense in depth is in there. So we're trying to build resilient systems, and what we've been doing for the last few decades is disaster recovery. What we've been doing more recently is chaos engineering, and really cloud is the enabler for chaos engineering. It gave us enough automation and enough ability to switch resources in and out that we were able to start thinking about introducing chaos into our systems. But this is done by a few organizations that are sort of leading edge, and they kind of do it occasionally most of the time. So you do occasional disaster recovery or chaos engineering testing. What we really want to get to is resilient critical systems where we know that they're resilient and they're going to be resilient all the time. And we test them often enough that we know it's going to happen. So chaos engineering, the history of this. Back at Amazon, Jesse Robbins had it on his business card, the master of disaster. He'd go and simulate entire data center failures for Amazon. This is for not for AWS, this is for the Amazon.com business. Back in 2010 at Netflix, Greg Orzel came up with the idea of building a chaos monkey to enforce autoscale stateless services. We want all our developers to build services that you could run in an autoscaler. When an autoscaler scales down, it removes a machine. So you have to always be able to remove a machine. So the chaos monkey went around removing machines, and the autoscaler would put it back, right? So that one proves that you can remove machines without having the software fail in some way, and it also shows that you can come back up, right? So now that's an essential capability for any auto-scaled service, as it should be able to run with a chaos monkey. We open sourced a bunch of this in 2012. Colton Andres, who was at Amazon and at Netflix, left Netflix and founded Gremlin in 2016. You can see a lot, if you want to see a lot more stuff on this, they've probably got the most content out there right now. The Chaos Engineering book came out in 2017, and we're starting to see more adoption starting in 2018 through 2019. A few more startups on the way. So what does this look like? You're trying to model the infrastructure, switching, application, and people, and keep all of this working, and all of this needs to be tested. You've got a bunch of different tools, and it's a bit like the security red team trying to break into your system. They're trying to socially engineer their way in to get people to find a way in the same way as chaos engineering team is running game days to make sure the people understand what to do when there's a failure. And all these different layers. The switching layer is the pit that switches traffic between systems when there's a failure. It's probably the least well-tested code in your system, right? The system, if you have a failover system between two data centers, the code and the practices for doing that are, if you don't exercise them, you're depending upon incredibly poorly tested code. And that's just a recipe for disaster. And we've seen many disasters where something went wrong, and then something, because of the failure handling, it got worse and worse and worse, right? All right, so you can only be as strong as your weakest link. Dedicated teams are going to need to, will be needed to find weaknesses. it's a systems problem. It's not the failure of a human. It's a lack of safety margin that causes failures. So what you need is experienced staff that know how to handle failures. They know how incidents work, robust applications, dependable switching fabric, and a redundant service foundation. So cloud gives you the automation that led to cloud engineering in the first place. And as data centers migrate to cloud, we're trying to replace these fragile and manual disaster recovery processes with something much more standardized and automated. And testing this is going to move from a sort of a scary annual experience to something that's continuously tested. It's every weekend or it's running all the time in the background, depending on what kind of system you're running. So that book I mentioned, this is kind of a summary of that whole thing. You can go find it on the Executive Insights section. It's kind of a glossy 9-page little story written out. Take it, give it to your executives. I'm giving another talk this afternoon. I think it's called Failure is Not an Option. I think it's ARC203 from memory. And there's 3 of us speaking. We're talking in much more detail about failure models. I'm talking at the end about failure modes, and there's much more there about highly available architectures. Okay, and then this is my book list, like all the books I mentioned and all the books I mentioned on my talks, I just added them to this Amazon whatever. It's like an Amazon list that's public. And I store a bunch of slides and video links, and if you want to see how the spaceship animation works, I think that deck is on there. I store PowerPoint on GitHub in the hope that one day Microsoft might enable pull requests on individual slides, but doesn't seem to be happening just yet. So that's what I had, and thanks for listening. Best wishes for your transformation. I hope you have a great reInvent. Cheers.